Hi, today we are going to talk about packaging your Clojure products. In particular, we will talk about packaging libraries and applications into the jar files, and we will do this using the tools.build library that is a part of Clojure. First, let's talk about what the jar files are. Jar is a format that came to us from Java world, and since Clojure runs on JVM, it also extensively uses this format. Jar acronym stands for Java Archive, and it is actually an archive, a zip archive, that contains different files and that has extensions .jar. As a zip archive, jar can contain any kind of files, but some of them have a special meaning for your Clojure projects, and I depicted them on this diagram. MANIFEST.mf. As official documentation says, this file contains information about files packaged into a jar. For us, the main feature that we will use in manifest.mf is the possibility to specify an entry point to your application. There are a bunch of other features in Manifest, but we won't cover them here, and I will leave a link to official documentation under this video. If you're creating the jar file using tools.build library, like we will do today, you don't have to create a manifest.mf manually. It will be created for you automatically, but we will later discuss how you can adjust it and add your own key value pairs, your own settings to that file. Another important file that you can create in your jar is pom.xml. In the Java world, there is a super popular build framework called Maven, and that framework uses pom.xml files to store project configuration and information. This framework has own type of repositories called Maven repos. And in Clojure, we don't have to use Maven as a build tool, but there is high chance that you will eventually want to upload your project to some of the Maven repos. For example, to the most popular in Clojure world is Clojars. And to be able to upload your jar artifact to some Maven repo, you need to have a pom.xml inside your jar. Another files that you can find in your jar are .class files. These are files with compiled Java bytecode. You will get them as a result of compiling your Clojure sources. Also, you may find in your jar file the actual Clojure sources, your CLG files. And of course, you will have resources. Or maybe you don't have, but you can have. Let's take a look at another diagram to discuss how your jar content will differ depending on what you are creating, jar for library or jar for your application. When you're delivering a library, you have a choice on what to pack into your jar. You may pack only bytecode files, only compiled bytecode, or you can put only Clojure source code, or you can pack both your compiled files and your Clojure source files. The difference is that when you're putting into your jar only compiled bytecode, it will be used as is. If you are putting only Clojure source code, then at the moment when your library used by some application, that source code will be compiled and that bytecode will be used. And in case of third option, when you are packaging both your bytecode and your Clojure sources, bytecode files will have a preference unless Clojure code is newer, then it will be compiled and used. When you are going to pack your application into the jar, and the jar is intended to be executable, the situation is a bit different in comparison to library. What you should pack for sure into the jar is your compiled bytecode for your application, but you also should have to put all the dependencies of your code inside the jar and any other files and resources that you need. Such kind of a jar with all the dependencies calls an uberjar, and you will meet this term later in tools.build API. You will find a function called uber, and it is about creating that kind of jar, uberjar. Now let's try and use tools.build library to create different jar files for library and for application. We'll start from the example for library. Let's create a project called simple leap. It will have some sources with namespace my mess. And here will be file some CLG. We will have our deps.edn, and we also need a resources folder. And in here we will put some resource like my mess resource txt. It will say hello from my mess library. Now, inside of sum slg, we will create a MyMessSum namespace with a sum function. And it is quite simple. It returns a sum of its arguments, and it also prints information, content from the resource file, from the resource files that we would created here. Please don't do like this in real projects. There is no real reason to mix in such impurity into simple function like sum, but I will do this here just only as an example of reading resources and reading resources from jar files. So please, never in real projects. Our deps.edn will contain simple pass key. So now we have a very simple library with one function, and we want to create a jar for this library. To do this, we are going to use tools.build, and this is a library that goes with Clojure. And there is an idea behind that library. The idea is that you can describe your build process for your project in Clojure language itself. And tools.build provides you with a list of functions that will be useful to do this. So let's add a namespace where all our build functions will reside. And we will create a file outside of src folder. We'll call it build.clj because we don't want to interfere it with any sources of our library. For that, we will create a simple clean function that removes target folder. Target folder is where we are going to keep all our build artifacts. And we are using here delete function from tools.build API to remove that folder. To run that function from command line and to not interfere with our project code, we need to create a separate alias inside the deps.edn. So in deps.edn, we creating an alias key, and we'll create a new alias called build. It should has a deps key inside. Here we will put a dependency information about our tools.build, and we need to specify an as default key. It will be build, and as default specifies default namespace that will be used when we are running some functions from that alias. In our case, this is build namespace. And dependency on tools.build, we can go to the official repo of that project, and in readme we will find here the detailed information on what should be used, what info should be used to correctly reference tools.build. We put it here, and now when everything is in place, we are going to call a Clojure command line interface with t option with our namespace and pass a name of clean function to it. Let's run it. Okay, as you can see, our function was invoked because we see that folder target removed function. We can even double check and create right now a target folder and run that function again and make sure it will disappear. Yeah, we don't have the target anymore. So we have a clean function that will be helpful later when we will create a more useful build functions. Now let's create a jar function that would be invoked when we are going to pack our library into the jar file. I didn't specify this before, but every function that you are going to call from Clojure command line interface with t option should contain one argument. We are not going to use that argument, but if a user passes on command line some additional key values pair, that will go into one map and will passed into that argument. We're not going to use it, but anyway, Clojure command line sends default argument nil to our function, so we are just putting underscore here to ignore it. Let's write it down, everything that we need to happen into the jar function. As a first step, we need to clean leftovers. On every call to jar function, we will build something into target folder, and that target folder will contain a lot of intermediate files. So on every new run of that jar, we need to clean up that. Next, we are going to create a library that will contain only source code without compiled code. So what we need to do is to copy the source code of our library into the target folder, where it will be later used to create a jar file. And of course, we need to copy all the resource files. Next, since we are creating a library and we'll probably need to put it into Maven repository someday, we need also to create a pom.xml file. And the last step is pack a jar. So everything that we created, all our sources, resources, and created pom.xml, we need to pack into a jar file. To make all these steps, let's add a couple more useful defines to the top of our file. Let's create a def called jar content, and this would be a path to folder where all our files that will go into jar will reside. It would be target/classes. We will need a define for library name, one more for version, one more for jar file name. It will be resided in build folder and formatted with a library name and its version. And also we need one more define for basis. You don't really have to go deeply into what is basis. In general, basis is a big structure that contains information collected from all deps.edns of your project, and it is a list of all the libraries your project depends on, all the class paths created for your project, and so on. And some functions in tools.build API uses that basis, and you're creating it also with the help of create basis function from tools.build API. Now when everything is defined, let's go to fill in the jar function content. First function that we need to call is clean. We already defined earlier. The next function is a function from tools.build API. It is called copy_dir. We specify what folders we are going to copy and where, and we will put them into our jar content folder that would be target classes. Next, we need to create a pom.xml. To create pom.xml file, we will use a write pom function from tools.build. It gets plenty of argument. It takes a folder where pom.xml should be created, name of library, version of library. Also, it uses basis to fill the content of pom.xml, and it uses src folder to fill some sections of pom.xml with information about library. And the last step is actual packing a jar. We need to call a jar function from tools.build library. It takes a class dir key inside argument map, and that contains a folder that we need to pack into the jar. And it takes name of jar file. And we can add a small print that jar file is created. Now let's try and run it from command line. To do this, we are calling Clojure command line interface with T option, with our created alias build, and we specify a jar function that should be run. Ta-da! We have a jar file created at target folder. Let's take a look. Yep, here it is. We can take a look inside of that jar folder. I have a VS Code extension called jar view, and it shows us all the content of the jar. So we can see that there is a MANIFEST.mf file. It is quite simplistic, just generic information. We have a pom.xml file inside Maven directory. This is information about our library, its name, its version, and also its dependencies. And we also have a source code of our library inside, and also we have our resources here. So our jar is fully packed. Now, to modify manifest file, to add more key value pairs to it, we need to add one more key to our call of jar function, key called manifest. And as a value to that key, we will put a map of some key value pairs that we want to go into manifest. Let's add some silly like my key, my value. Now we need to regenerate our jar file. To do this, we will call our command line function again. Okay, new jar file created. Let's take a look into it. And we see that manifest.mf contains now my key and my value pair. So you can put everything you need inside of it using that way. Another question you may ask is how to modify pom.xml file. That works a bit different in comparison with modifying manifest.mf. In order to do this, you need to create your own template pom.xml file, and that template file will be merged with the default one created by write_pom function, and the result of that merge will go into jar. So to create a template pom.xml file, let's reuse the already created one. We'll take our pom.xml from target folder and we'll copy it on the same level as build.clj. So let's use that file as a template one, and we will add a description to it. What we'll say here, let's say this is the best SAML library, which is for sure not true. Okay, now let's generate our jar file again. But before, let's update the version number to see how it works. And we expect that version number will be taken from the script, and the description will be taken from the template pom.xml file. So we're running jar function again. Okay, now we see that another jar file for version 002 created. Let's take a look inside of it. Yep, we can see that version is updated. It is 002, and description is also in place. That means that our template pom.xml file was merged with the one generated by write_pom, and the result of this merge was written into the jar. That was all about libraries, but now let's create a jar that contains a runnable application in Clojure. Let's create a new folder for it, for our app. Let's also add some resources here. We'll add a folder dev with file core CLI, and this core will be quite simple. It will define one main function that will call our sum function from the previously created library. So we are going to reuse it and add it as a dependency to our application. And also it will print something from a local resource file. Our deps.edn for the application will be very close to the one that we had for library. The alias build is the same as we had in the library, and only difference is that application has a deps section that specifies the dependency on the library we created before, and we reference that library locally from the jar file using the local/root key. Now let's take a look at build.clj content. It is pretty similar to what we had for library. Instead of jar file name, we have here an uber file name, and I'm reminding you that we are creating a uberjar. It is a jar that contains code of application, but also all dependencies of it. And instead of jar function, we have an uber function, and its structure is following. First, we need to clean our target directory, similar way as we did for the library. Next, we are copying the resources to the jar content, and we here don't copy the source files because we don't need them. We actually can copy them, but they will be treated as just regular files, just resources, so they won't affect any execution of jar. Compile CLG function of tools.build library takes source code of Clojure, compiles it, and puts the bytecode files into some folder. In our case, input folder for our sources is src, and the output folder where our compiled bytecode files should go is our jar content. And also that function uses basis. And the last function that we call here is tools.build uber. Uber is the function that actually packs your Uber file. It puts there all the bytecode you compiled on the previous step. It collects all the dependencies that your application has and also packs them into Uber. And it also specifies what is the entry point for your application. And here you see the key main. It tells what is namespace is an entry point for our application. And it is important to mention that for this line to work, in the namespace that you are going to use as an entry point, inside the namespace declaration, you need to specify gen class directive. And this directive tells the Clojure compiler that for this particular namespace, separate bytecode files should be generated. And that bytecode files can be found by Java when you're running that uberjar. So now let's try to run it. We're running the command line with T option, with our build alias, and with function uber. Okay, we got an error, and I believe this is because we don't have 0.1 jar anymore, so we can change our dependencies to version 2, because this is our latest version that we were generating. Let's run uber again. Perfect. It says uber file was created. Now let's try to run our jar. To do this, we need to run java command with jar option and specify the path to our jar. As we can see, we have some exceptions that says cannot open nil as a reader. Okay, we in core CLG, we name app resource txt. And here we created app resources, so we need to fix it. Generate one more Uber, and we can run it. Perfect, it works. As you can see, it prints information from library resource file, it invokes library, and it actually prints information from application resource file. Let's take a look inside the jar. Here we have it. And you can see that in comparison to jars that we had for our library, this one is quite huge. It contains all the libraries that we depend on, all the Clojure stuff that goes with our application. Also, dependency on my mess is also here. We can see its content, and we can see actually our application in depth. So tools.build is a wonderful library that allows you to create your own build scripts in Clojure, and they can be of arbitrary complexity. Tools.build contains a lot of other functions that we didn't cover today, but I encourage you to visit the official documentation and take a look at them, because there are useful functions like zip and unzip for working with archive, process function to run arbitrary process on your machine. So you can write like any script with it. Maybe almost any, but very convenient one. If you did like the video, I encourage you to subscribe and put the thumbs up. Also, if you want, you can make a donations. All the links in the description. Half of the donations will go to the humanitarian aid for Ukraine, and half will be used to make next videos. So see you later. Bye.